Hello, first period students. Mr. Lawrence here, and I'm going to quickly do problems 2 and 3 from the board because I don't know if I'm going to be here or not, so you'll see it in the video. Anyway, and then we're going to do some quadratic application problems. Okay, so now let's make sure we're taking our time and doing this right. First thing I'm going to do is find the discriminant. To do the discriminant, I need A, B, and C, right? 3, 1, and 1. So the discriminant will be B squared minus 4AC. Oops, I have a small mistake there. Let me catch that right away. I need a 3 in there. And then C is 1. And so I'm going to get 1 squared minus 12, which is negative 11. The discriminant is less than 0, so there will be no solutions, right? B squared minus 4AC is greater than 0. We have two solutions. B squared minus 4AC equals 0, we have 1. And B squared minus 4AC, we have no solutions. All right, memorize those in order. It'll be a lot easier. So since there's no solutions, I'm not going to waste my time looking for using the quadratic formula because it's going to tell me the solutions, but there are none. So I'm going to go looking for the vertex, and I'll do negative b over 2a, right? The first part of the quadratic formula. And so in this case, that'll be negative 1 over 6. Now I know the x-coordinate of the vertex. I also know the axis of symmetry, right? The axis of symmetry is going to be x equals negative 1/6. Now I'm going to come down here to the graph. Negative 1/6 is going to be kind of hard to graph, but it's going to be really close to negative or to 0, won't it? So I'm going to get a nice thin vertical line like this. Oh, that's not very thin, Mr. Lawrence. I know, I'm going to make it thinner. Remember, this is not a part of the parabola. This tells me what vertical line the parabola is symmetrical, but I don't know if you can see that. I better do that. All right, so it's going to be something like that, okay? The vertex is going to be on that green line. Okay, now, to find out where on that green line, I have to take the negative 1/6 and put it in for x. In fact, I'm going to make a table here, and I'm going to put negative 1/6 in. All right, and so I'm going to show my work. Some of you are just running to the calculator too quick. Don't run to the calculator. Squared plus negative 1/6 plus 1. All right, so I'm going to get 3 over 1 times 1 over 36, which, by the way, will simplify to 1/12. So 1/12. Then minus 1/6. So that's minus 1/6, and this should really be equals and equals. And then don't forget to add the 1. And it looks like I'm going to be adding 12, so I'll do 12/12. All right. So this is half of that, which means subtracted, I'll get negative 1/12 plus 12/12, which will equal 11/12. All right, so 1/6, negative 1/6, and 11/12 is going to be something like that. I like that. I like the fact that the vertex is above the x-axis because it's going to open upward. A was positive, and I know it's not going to cross the x-axis, so that's a good thing. All signs that I did it right. Now, in my table, I love to use 0, and 0 might not be the best choice in this one, but I'm going to go ahead and use it anyway. I'm going to put 0 in for x, and when I do that, y is going to be 1. So it's going to be sitting like right there, okay, the point 0, 1. And then I went 1/6 to the right. I'm going to go 1/6 to the left, which would be a negative 1/3. How do I know that? Because 1/6 and 1/6 would be 2/6, which would simplify to a third. And so at negative 1/3, about the same distance, I'm going to be there. And the parabola is going to look something like this. Okay, now if you wanted to put other points on there, you could, but the fact that you identified 3 of the points, that tells me you understand what's going on. All right, here comes problem number 3, I think. Where are you, problem 3? There you are. Oh, there you went. Stop. Okay, so remember, first step, find the discriminant. So I'm going to go ABC, ABC. Easy as negative 1, 0, negative 4. Discriminant B squared minus 4ac, which I think is going to be a negative 16. No solutions, no zeros, right? So I'm not going to use the quadratic formula on this one. Go find the vertex, which will be easy because x is going to equal 0 over negative 2, which is just 0. My vertex is the y-axis. It's the line x equals 0. This will be symmetric about the line x equals 0. All right, so if I make x 0, I put it in there, and I get y to be negative 4. So down here on the graph, 0, negative 4 is on my graph. Okay, 0, negative 4. Now, I normally like to put 0 in. In this case, I can't. So I think I'm going to go ahead and put 2 in. All right, and so I'm going to get the negative of 2 squared minus 4. That's what y is going to equal. And when I do that, I'm going to get 2 squared is 4, and make it negative. Minus 4, it'll be negative 8. So negative 8. Using symmetry, I'll go 2 in the other direction, and I'll get a negative 8 again. Something is really acting weird with this program. I'm not sure what's going on. So I got 2, negative 8, and negative 2, negative 8. So we're going to have, whoop, there we go. And for some reason, it's not showing up. Okay, so my parabola will do this. Well, that's actually pretty good for not being able to see. That one was inside a little bit. Okay, don't forget some arrowheads. And there you go. That's going to be really annoying if it doesn't show up until a second later. All right. So there's the two problems. Obviously, you're supposed to hit that point there. I do apologize. Let's get on to the quadratic application problems. All right, it says Bobby drops a rock off of a cliff. The rock is 120 feet off the ground when he drops it, of course. When will the rock reach the ground? At what time will the rock be 20 feet off the ground? Well, to do this problem, you need this blue equation I have written down here. H equals negative 16t squared plus or minus v sub o t plus h sub o. Well, h sub o is going to be your starting height. Starting height, or original height. Okay. T, of course, is time. V sub o is your original velocity or starting velocity. Starting velocity. I'm recording a lesson. Okay, so T is time again over here, and H is your ending height. Ending height. Okay, so to do this problem, all I have to do is fill in the information the story tells me, and then I'll apply parts of the quadratic formula to it. So let's see what we know. We've got this 120 feet, and that's where the rock starts. This must be h sub 0. Okay. Now we're looking for when it'll hit the ground. Well, h must be 0, right? Because hitting the ground would mean you're 0 feet off the ground. The t we don't know because it says when will the rock. When will the rock? That's a question of time. Now what's the starting velocity, v sub o? Well, he's dropping it. He's not throwing it, so the starting velocity is 0. So this starts off to be 0 for h equals negative 16t squared plus 0t plus 120. Now the 0t is really unnecessary because 0 times t is 0, so I essentially have this quadratic equation. Okay? Now, just to get a picture and see what this looks like, I'm going to go to my graphing calculator. I'm not going to do it on the graphing calculator, but I'm just going to get a picture. And let's see if I've got it here. I think that might be it. Yeah, negative 16x squared plus 120. And so there's the parabolic path that the ball will follow. Notice as the time increases, the vertical distance gets larger. Did you catch that? See right here. Oops, not going to let me write on that. Nope, it's not going to let me write. Okay, so 1 second is here. Okay, and look, the rock only dropped a small amount, right? this amount here. Really wish that would let me, I wonder if I could take a picture of it, and then if I take a picture of it, then I can do what I want to do. So let me get my camera out, and let me get back up here. And all right, there we go. Hope you smiled for the birdie. Okay, so yeah, there it is, perfect. All right, so notice that this is the first second from here to here, right? That's the first second. 1 second. Notice the rock started at that height, but in that first second only fell this distance here. Not a very large distance. But in the second second, this period here, it's also 1 second, but it's the second second, right? The rock has dropped a larger distance, a longer distance. It has fallen more. Just compare these lines. See, it's much larger, even though it's not drawn very well. If I want to put a grid on, I guess I can. Extend that across. This will help me a little bit. Okay, and then, all right. And so as you look at this, this first second, it's here. It's only fallen about this much, right? That's the change in the vertical distance. But on this one here, let's see, the second, it's all the way down here to there, and so that one has fallen. Let me see, let me do it in, blue's a bad choice. It's gone that distance vertically. So notice the size difference. It's speeding up as it falls. That's due to gravity's pull. Of course, it gets faster and faster. It does stop at a point. It can't go any faster. It hits what's called the terminal velocity. But we won't be examining that. Okay, I'm going to get rid of this because it's in my way. But I wanted to make that point to you. All right, and let's go back here. All right, so I saw what the picture looks like, and now I'm going to go to the quadratic formula. Now I know the discriminant's going to be positive because this thing has to hit the ground, so there's got to be at least 1 0. So I'm not getting all bent out of shape about finding the discriminant, okay? So I'm going to go t equals the negative of b plus or minus the square root of b squared minus 4ac whole thing is over 2a. And I'll simplify as much as I can here. This 0 part actually becomes irrelevant. And what am I going to get under there? Let's see, I got a 416 and 120. I knew this earlier today because this is like my third take on this video, but that's okay. So let me go here. Let's go 4 times 16 times 120. And I get 7,680. So I have plus or minus the square root of 7,680. And that's all over negative 32. Now, one of these is going to be positive, one of these square roots, and one of them will be negative. I'm not interested in the positive one because when I divide by negative 32, I'll get a negative answer. So I'm going to go ahead and take a negative of the square root of 7,680. And I'm going to divide that by a negative 32. And I get a negative 2 74 hundredths. All right, so it'd be about negative 2 74 hundredths seconds. That's when it'll strike the ground. Okay? All right. Let's try another. Oh, no, we got part 2. What time will it be 20 feet off the ground? Do you remember Alex Turchek talking about like maybe there were somehow being 2 zeros or something, and he had them at different heights. And I said it was really intelligent. It wasn't quite right where we were going, but we were going to get there. Well, if I want to know where it is 20 feet off the ground, everything is going to stay the same in the equation. This part turns to 0. We have a plus 120. But my ending height will be 20 because it's almost like I'm stopping the rock when it hits there. So then I subtract by 20 because I want my equation to equal 0. We always want quadratics to equal 0. And 0 will equal negative 16t squared plus 100. And now I go to the quadratic formula and see it might give me 2 answers. I don't think it will, though, because the rock's starting at 120. But a question like this, there are situations where I will get 2 answers. So let's see here. I'm going to do my t equals the negative of b plus or minus the square root of b squared minus 4ac, and that's all over negative 32 again, 2a, right? Okay, so t is going to equal plus or minus, that 0 is not going to matter. The square root of, let's see, 32, 64, 6400. Oh, I like that. That's a perfect square. Divided by negative 32. So that's the same as plus or minus 80 over negative 32. I don't care about the positive one because it won't yield a positive time. It'll give me a negative time. So let's see here. Let's take 80. Oh, I'm sorry. I guess it should be negative 80 divided by negative 32. And that'll get me 2.5 seconds. And it actually came out even, so I don't have to do approximately. I'll say at 2.5 seconds, it reaches a height of 20 feet. Okay, let's try another one here. Let's see. Let's try this one. And then the bell is going to ring on me. So, all right, a rocket is launched off a launching pad that is 20 feet high with an initial velocity of 200 feet per second. Well, it's time for a picture. Okay, here's my launching pad. And I know that's 20 feet. And let's see, I need a rocket, so something like that. Okay, there's my rocket. Okay, and it's going up at 200 feet per second. So it's going to go up like this and come back down. And we know the V sub O is 200. Sorry, 20. V sub O is 200 feet per second. And we want to know how high will the rocket go, after how many seconds will it reach that height. That sounds like a vertex question to me. So I'm going to use the equation x equals negative 16t squared plus or minus v sub o t plus h sub o. That's a t. All right. I'm going to leave that as h for now. Okay, negative 16t squared plus 200. How do you know when to use plus or minus? Well, is it being thrown upward or downward? And in this case, it's being shot up, and so therefore it's a positive velocity. Okay, and the starting height, original height, is 20. All right, so how high will it go? Well, I'm going to try to find the vertex. So I'm going to go t equals the negative of b over 2a. Oops, negative 32 there. So t is going to be approximately, and I'll have to do 200 divided by 32, or negative 200, divided by negative 32, and I will get it about 6.25 seconds. And that's actually came out even, so I'm not going to use the approximately equal to. It's going to be about 6.25 seconds. I just found out at what time it will reach its maximum height. It'll take 6.25 seconds to get up there. How am I going to figure out what that maximum height is? Well, I'm going to plug that in to this. And I'm going to go ahead and go to my graphing calculator on that. And so I'm going to get negative 16, 6 1/4 squared plus 200 times 6 1/4 plus 20. Looks like its maximum height is going to be 645 feet. So h is going to equal 645 feet. And it's going to reach it in 6 1/4 seconds. Okay. Problem number 2, no, problem B is at what times will the rocket be 420 feet off the ground? So it's done almost the same way, except the 420 is going to be the ending height. I've got negative 16t squared plus 200t plus 20. And I want it to equal 0, so I'll subtract 420 from both sides. I'll get 0 equals negative 16t squared plus 200t minus 400. And I can find the discriminant, but I'm pretty sure there's going to be 2 answers. So I'm going to go ahead and go right to the quadratic formula. So negative 200 plus or minus the square root of 200 squared minus 4ac, and that's all going to be over 2a, which is negative 32. So I'm going to do some simplifying in there. Negative 200 plus or minus square root of 40,000. It's going to be minus, let's go calculator on this. So 16 and 16, I think it's 256, right? 16 and 16, 256. So 256, 0, 0. I think that's right. Over negative 32. And so then t is going to be equal to negative 200 plus or minus, okay, I'm thinking 14,400, right? 39, yeah, over negative 32. So I'm going to go to my graphing calculator at this time, and I'm going to go parentheses, negative 200 plus the square root 14,400, and I'm going to divide, oops, that didn't belong in there, sorry, close that parenthesis now, and I'm going to divide it by negative 32. When I do that, I'm going to get 2.5 seconds, and then I'm going to do the same thing, only I'm going to change that to a minus. And I'm going to get at 10 seconds. So I'm going to get, for part B, I'm going to get at 2.5 and 10 seconds. How can that be? Well, the rocket's going like this. And so it's going to hit that height here, and then again over here. All right, I'm running out of time here. The bell's about to ring. The third question is, after how many seconds will it return to Earth? This is just straight quadratic formula. So I do the quadratic formula on 0 equals negative 16t squared plus 200t, and it's starting 20 feet off the ground already, plus 20. Yeah, because it's on a platform. Just do the straight quadratic formula on that. And if I'm in class, we will talk about it tomorrow. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.